Hi. I want to start off by telling a story that I hope is relatable for many of you. Before coming to Apollo, I worked at a product company, and we had a lot of static designs for things like success screens and empty states. Here's an example of what that would look like. Usually a bit more production value than this, but you've got that happy little tree over there. And then our designers had a great idea to sprinkle a bit of personalization onto these screens to keep users more engaged. So something like that. And from a product perspective, that's probably a great idea. But as a developer, it's hard to avoid groaning a little bit because now you have to add all these dynamic pieces to these previously perfectly happy little static components. Thankfully, React and GraphQL on Apollo makes this really easy. Here's some pseudocode using the old-fashioned function as children pattern. Make a query and use the data. You could go a step further and make that into a component that makes a query inside of it. And I was pleasantly surprised that Apollo client is intelligent enough to duplicate network requests. So if you sprinkle a bunch of these throughout your page, you only still make one network request. And the next time you need it, it's already cached, so it just pops up. But if you've done this before, you might know what's coming next. If you use Storybook or if you have tests on these components, now everything's broken. So query doesn't know what to do without a provider. And the tests will have the same problem. It's just much more fun to see these scary red screens. Enter mock provider. I know a lot of you probably already know how to use this, but for the sake of having everyone on the same page, please allow me to quickly go over its API. You pass it an array of mocks, one per request that your component will make. And when this runs, the app makes a query. Mock provider will look at what query that is, what variables were used to make that query, then go through the list of mocks to find a match, and then return its results. Because I have limited space on this slide, I had to ellipsize some details. Let me show you some concrete code. So this is an app that I made for the presentation. It's a Yelp clone. My idea was if you're building an app, this would be like a screen, a single screen on that app. And also thought if lunch wasn't provided, this presentation would be doubly useful. I might have gotten a bit carried away here. Look at that. Anyway, the whole page makes one query when you load it. It asks for the list of restaurants, the names, ratings, the locations, and then when you select one, it fires off a separate query to get its address. That's a bit small there. Sorry about that. So this info pops up with the address. Those are separate queries because you might not need them. So why load it if you might not need them? So now let me show you the storybook for this page. Looks very similar to the app. And now let me show you the reason why this isn't a red screen. We've got this. That looks makes sense. It's like mock provider. You got past the list of mocks. Let's go into there and see what that looks like. So here it is. Up here, you've got the query. We're importing the query from the component and the variables that that component uses to make that query. Let me make that a bit bigger. And then down here is the response. I copied and pasted this from the network tab. So that makes sense, right? That makes sense. It can be, if you use this a lot, though, it can be a bit cumbersome sometimes. Because remember when I said you have to make one mock per request that you make. And also remember how each marker sends off a separate query. So what happens if I do that in the storybook? Bam. What happened there? Oh, I should make this bigger too. So no more mocked responses for the query marker info query. That makes sense. I didn't provide a mock for the marker info query. The only mock I provided was for restaurant query. So don't provide a mock, don't get a mock. That's fair. All I have to do is add more mocks. The file's already a bit big, but it's in its own file, so what does it matter? I won't do that here though. Another reason why this can be a bit cumbersome is, for example, if you wanted to, for some reason, if you wanted to add a new field to the initial query, let's say that you want to know how many restaurants, how many results there were in total. Because this is just a demo POC thing, I didn't have pagination, but there are way more restaurants than the, I think, 20-something that I listed on that page. So let's ask for the total. And this won't look very pretty, but just so that we can see what that number is, we might need to generate types. Data dot, am I doing this right? Data dot search dot total. Oh, not in there. Whoops. Businesses.maps. No, that looks right. Let's save this, and then I'm going to generate the types so that TypeScript doesn't yell at me. Whoop. And let's go back to the demo. So hopefully we'll see a total result somewhere. Uh-oh. Did I not? Whoops. Did not save. Running CodeGen, and after it finishes, object is possibly null. Oh, right, TypeScript. Data, add some guards there, data, and data.search. All right, we've got 137 results. Phew. 137 results, that's how many we have, even though we're only showing this many here. Now let's look at the storybook again. Now it's broken again. What's the problem this time? So we've got a warning here that says missing field total in business. That makes sense. I just added a new field. I didn't provide a mock for that field, so I'm going to have to go back here and make sure to add the field that I requested. This is going to go in here. Let's say 130. And now it's working again. So it requires a bit of maintenance. When you're working on your app, make sure to keep your mocks up to date. So this is the same, the example I used here is for Storybook, but the same thing happens when you are writing tests. The good thing about tests is when they fail, you usually have CI covering those components that will yell at you when they fail, but I don't think as many people will have CI covering Storybooks. So this thing could happen where you make a pull request that updates your app, and then it accidentally breaks the Storybook, and then people don't notice for maybe a couple days or a couple weeks, and that could be a bit embarrassing when someone does find out. How could you not be checking all the things that you're doing? So that's definitely hasn't ever happened to me, and wasn't why I went looking for something that might be a bit more convenient. But there is something that could be a more convenient way to go, and it comes with a big disclaimer. What I'm about to show is not Apollo's canonic recommendation for dealing with mocks for tests and storybooks. It's something that I puzzled together before coming here because, like many developers, I'd go to great lengths to avoid tedious tasks. And after I came here, I found out that 3 other people at Apollo had, I believe independently from each other, come up with the same idea. There was Jake Dawkins, Apollo architect, has a branch tucked away somewhere. If you find it, it's like an Easter egg. And Tim Hingston, a front-end lead, made an implementation of this for Apollo Engine, our front-end. And Sashko, the former open source lead, wrote an article on this 3 months ago that's on Free Code Camp if you want to look that up. Our approaches have slight variations, but the main idea is the same. It revolves around this add mock functions to schema function from GraphQL tools. So if you mostly work on the front end with GraphQL, it's possible that you might not touch GraphQL tools very often, but when I saw this for the first time, this opened up a lot of possibilities, because if you give it an executable schema and then you call add mock functions to it, and if you also optionally provide a dictionary of resolvers, then you can start running the GraphQL function against this mocked schema and start getting data back. So let's take a look at what that would look like in the code. This is the storybook for the automocked provider. Let's go look at what the automocked provider looks like first. So this code is all on GitHub. If you want to look at it a bit closer afterwards, I'm not sure how much time you have. I might not go too deep on the implementation of this, but I'll quickly walk through what you will need to provide to it. You need to provide a dictionary of mocked resolvers. If you don't, then it's just going to use the default ones, which aren't great sometimes. It gives some really rudimentary data. You also need the type defs here, just in this specific implementation. I have the GraphQL schema as part of this repo. I'm downloading that from using Apollo CLI. and then using GraphQL introspection to convert that JSON into schema.graphql. So if you don't want to keep your schema inside the repo, or if you don't want to have this locally, there is an option where if you have an endpoint and the endpoint's introspection is enabled, then you can hit the endpoint, grab the introspection, and turn that into a remote executable schema. I'm not doing that here because you probably don't want to do that if you're using this for tests, because that adds a network request before your test can run. So this is automocked provider, and let's see where this is used. This is the automocked storybook, passing in some resolvers. This might be a bit too much to look at right now. Let's make that a bit simpler just for the initial example. 1 second. All right, let's see what that gives us. So these are the automocked results. Oh, 27. It's already in there. Nice. Let's get rid of that. Doesn't look that pretty. So what happens now when I click on one of these? I get something back. You might notice that the data isn't all that great. The location's a bit scattered around, and the categories, hello world, hello world. So these are, where is that coming from? So in the automocked provider, we're providing resolvers. Let's click in here to see what that is. This is a dictionary. We have businesses, and then we have a file here, business. This is the type. This is the business type, and these are some of the fields on there. So you might look at this and wonder, what's the difference? How is this better than the other way? Isn't this still a lot of work? So one of the differences is that you don't actually need to mock everything. Let's see what happens if we take one of these out. So now that should, let's refresh. Now every business is hello world. So you might have guessed the default string, if you don't provide any mocks, it's going to be hello world. So that's one of the differences, is if you add a field, your components, your storybooks don't break, your tests don't break, you just don't get as good of a data. So you can kind of progressively enhance the quality of the mocked data that you're getting back. I think that's a pretty significant difference, because oftentimes, I think if you're mostly working on components that display data that aren't maybe all that important, it's not important for the, if it's not important for the test to break, if you don't think it's important for the test to break or the storybook to break, maybe it shouldn't break, if it's just meant to look all right. There are situations where you would want to have it explicitly break. Let's bring the name back. So what's another difference with this? Another difference with this is that because you're mocking queries, you're mocking types instead of specific queries, you don't have to make a different one for every query that you're sending. I think it should be safe to assume that usually the number of types that your schema will have, the number of additions that will happen, will be less frequent than the number of queries that you'll be writing for your app. So this is something that can be written and shared for any team that's working on the same GraphQL endpoint. Everyone who's working on that will be able to benefit from this repository of mocks. So it's like with the mocked resolvers responses, the amount of effort required, it scales linearly to the number of requests, where this is, I don't want to hazard a guess on the shape of that graph, but it's a lot smoother, and it feels like not the tedious kind of work. So let's take a look again at our automocks. Let's do an example of, so you can see how the categories are still a bit wonky. For example here, let's add a resolver for the category to see what that work would entail. So we know that it's called categories, and we want to return, let's say we want to return maybe between 2 and 5. New mocked list. And we're going to have to import that if it's, whoops. We're going to have to import that if it's not already imported. Oh, no suggestions. Oh, no. Mock list. Right. So that just tells you how many of whatever categories types is. This tells you how many of those to return. And let's make a new type resolver for category. And I know what shape this is because I downloaded the schema, which is, let's take a quick look. like if you were making this yourself, let's see what category would have. There we go. Category, it has a title. That's probably the only one we care about. It has a few other things we don't need to display. So we want categories title. So title. And what do we want to have as categories? Let's say that we want a sample of maybe sushi, pizza, and hamburger. And hopefully everything's good. There we go. So it's not intelligent enough to know to deduplicate yet. That is definitely a solvable problem. Oh, one of the other things I should mention is, so at least that looks better though. It's and that took very little time to put a proof of concept initial MVP mock for. And teams who are also using this, if they really care about not having two sushis in the storybook, they could make that better and everyone benefits. Another thing I should show is that this is the same kind of resolver that you would write. The arguments, the parameters are similar, so you get arguments in here, and if you want to use it, you can see how the ID, if you get an ID as an argument, this is passing that back. If you don't get it, it's passing a random ID. What this means is that the queries that are made for the list, the first query, because I have the ID here and I'm asking for information using the ID, it should match. Thank goodness it matches. So this is a separate query, separate data, but because it's running the same query, it's fetching the name for the same thing, and it's generating the address on the spot. So that is how to use that. And give me one second. So again, this idea is that your project would have a library of these and communally maintained, and would be something that you could have a bunch of people work on together. Caveats. Caveats. There are a few things to keep in mind. One is that this might be more work when providing a mock for data that's for time series metrics. So if you have a field that returns stats where you want the data viz to look like something to tell a story, it probably makes more sense to just grab a snapshot, because otherwise you're going to get by default random data that looks like this. So if you want to say make a stock chart, you probably don't want it to look just up and down wildly, because that's not going to look like what your actual app is going to show. You might fall into a rabbit hole. If you did try to make a function, you might fall into a rabbit hole of trying to figure out how to simulate Brownian motion or something, and I looked on NPM. There aren't a lot of packages with good download stats. So for those situations, it might make more sense to just grab a snapshot. But then again, if someone does figure it out, everyone who uses that will be able to benefit. Another thing to keep in mind is that results aren't stable by default. So if you're doing snapshot testing with Jest, or if you're doing visual regression testing with something like Chromatic, where any changes in the data cause the test to fail, then you're going to have to use something like seed random, which causes math.random to return deterministic results. Or if you're using Faker, Faker also has a seed method to have it do the same thing. So that way you don't get diffs every time, even when you haven't changed anything. And finally, you're limited a bit by the schema that you have access to. You can't write mock resolvers for types or fields that don't exist in the schema. One way to partially work around that is when you're using Apollo Engine, you should be able to request a schema that hasn't been deployed to production yet. So if you have a backend team who has pushed a schema, maybe they haven't written a resolver for it, so it's not live. But as long as the schema is in our engine, then you can download it using the tag. So those are the things to keep in mind if you want to try this out. Client-side mocks with local state. So this is a separate kind of idea. This slide was introduced rather last minute because Apollo Client 2.5 was just released this week with support for local state. So you can write resolvers and queries and mutations for the client on the client for client-side data. The obvious use case for that is to use it for the same things as you would for Redux to manage global local state. Another use case, though, is to use the client-side resolvers as mocks for types or fields that haven't been implemented on the backend yet. For example, if you know there's a field that's being added to a type and the teams have already agreed on the schema, the frontend can write a client-side resolver that returns dummy data just so that they can have something to work work on, and the backend can be working on the actual resolver parallel. So once the actual API's resolver is deployed, the front end can delete the client-side code. So that's one way to avoid having front-end development be blocked before the backend is done and deployed. I've been told that there is an article on the way, so keep an eye on Apollo GraphQL's Twitter. And here's a bunch of links. So the first one is the GitHub for where I put this. I think I probably spent, I don't know, nearly 20 hours on this. I got a bit carried away. The second one is an article that Sashko published that pretty much gives a breakdown of the same method here. One main difference is that their resolver merging function, I almost forgot to mention one very important thing. So one common use case is you might not be satisfied with just the mocks that are coming from this shared repository of resolvers. So this is something that you could do to customize the data that you get back for just one specific storybook. So in this case, we're asking for the common resolvers, and for business, we just want to tweak the coordinates. These are the coordinates for places around here. So if we save that and come back to this, so now this map is going to be a lot closer to home, and because it's now using the coordinates that were overwritten from this storybook to be this. So this is, I think that's a good mix, a trade-off of general purpose and flexibility to tweak, fine-tune. So the link from Sasha's article, he shows a snippet that does something that's very similar to this, but is a lot more robust. But it's a bit more complex as well, so I didn't think that might be as suitable for slideshow presentation. And then there's docs, seed random. You probably want to look into that. I actually only found out about this a couple of months ago. And the last, we have a community chat on Spectrum now. Last thing on there, Toronto.js. Many of you might already be on there. It's got a, hey Josh. We've got a, Christine. We've got a, wow, holy crap. Hi guys. We've got a really vibrant community on there. A lot of people, really good people, like to chat about really fun things. And last of all, GraphQL Summit. If you're looking for a reason, excuse to go to San Francisco in October, we've got GraphQL Summit 29th to 31st. Come check us out. And that's it. Thank you so much.